Alright, okay, so now we're done. Now that we're done with Krebs cycle, we have generated a lot of coenzymes, a lot of reduced coenzymes, NADH and FADH2. So where does all of this NADH and FADH2 go to? It goes to oxidative phosphorylation. Yay, we're at our final stage of aerobic respiration. Okay, so let's draw a little diagram. Okay, so this is your electron transport chain that is used for your oxidative phosphorylation. Okay, so let's now label the locations. So this part is your intermembrane space. And this is your mitochondrial matrix. So if you recall our structure diagram here, do you see that your ATP synthase, right? The head, the turning head, which is like this part, the circle part, is facing your matrix. And remember that your buildup of hydrogen atoms are in your intermembrane space over here. So it's a buildup of hydrogen atoms. Okay, so this is your big picture. Now let's go back to our oxidative phosphorylation. Okay, so oxidative phosphorylation takes place at the mitochondria, inner membrane. Okay, so let's look at our first molecule over here. This is your electron acceptor, and your electron donors are NADH. Let me use another color. NADH and FADH2. Okay, so they donate electrons into your electron transport chain. So your electrons go down the electron transport chain, and the electron is finally accepted by your final electron acceptor. So it's important that you know what is the final electron acceptor of oxidative phosphorylation, which is your oxygen. Okay, so your hydrogen plus oxygen and then your electron will give you water. So take note that oxygen is your final electron acceptor. Alright, okay, so as your electrons go down the electron transport chain, it loses energy, and this energy is used to pump protons across the inner mitochondrial membrane. Okay, so remember where your protons are accumulated? Your protons are accumulated in your intermembrane space. So they're here. We'll draw a lot of protons. And then your proton pump, which is this will pump protons against the concentration gradient using the energy released from the electron transport chain. Okay. Then now we have our ATP synthase. Okay. So your ATP synthase provides a hydrophilic channel for the transport of hydrogen atoms. Okay. So the hydrogen atoms are transported through the hydrophilic channel of your ATP synthase. ATP synthase. From the intermembrane space to your matrix. So your ATP synthase will use the proton gradient between your intermembrane space and your mitochondrial matrix to synthesize ATP from ADP and PEI, which is inorganic phosphate, using the proton motive force. Okay, so points to take note. Oxygen is your final electron acceptor. And lots of questions like to ask you what happens when oxygen is removed. So when you don't have oxygen, so oxygen is your final electron acceptor, right? So no more oxygen means no more electron transport chain. Because you need your final electron acceptor to accept all of your electrons. If not, your electrons are just going to build up in your electron transport chain and they cannot flow down the electron transport chain. So this will have implications on your production of ATP. So what is the importance of oxidative phosphorylation? Okay, the importance is that a high amount of ATP is produced. So if you need to be specific about your numbers, but for the sake of this summary, I'll just write lots of ATP produced. Okay, lots of, okay, you know what, I'll just specify it. So you know that in total 38 ATP is produced from aerobic respiration. 34 ATP comes from 34 ATP of 38 ATP is produced through oxidative phosphorylation reaction of your aerobic respiration. And your oxidative phosphorylation also serves to regenerate your FAD and NAD for Krebs cycle and link reaction. Okay, and 1 NADH gives you 3 ATP, 1 FADH2 gives you 2 ATP. Okay, but this number can vary, so make sure you check the question context. I think in one of your tutorial or assignment questions is not exactly 3 or 2, so just follow what the question says. Okay, that's all for oxidative phosphorylation. It's just this diagram, and make sure that you know how